Lesson 56, day 2, more common functions, x, 1 over x, x to the n, square root x, absolute value x, floor x, and sine x. I'm going to continue with our graphing today. Take a look at 2 more functions, and then you'll have time for work on your homework assignment. So the first function we're going to look at is the square root of x, and we're going to find the domain and range. As I said on Thursday, one thing that I like to do is start where the function is equal to 0. So I'm actually going to make a small table of values. And so the thing underneath the square root is 0 when x is 0 for this one. And when x is 0, the square root of 0 is 0. And I then said, take a look at 2 values that are less than the value that gives us 0 and 2 that are more than. Well, in this case, if I plug in anything less than 0, I cannot take the square root. So I'm not going to even worry about negatives, and I'm just going to look at other values that are greater than 0. And I'm going to pick them very carefully. I'm going to use 1, 4, and 9. And the reason I'm choosing those are perfect squares. So when I take the square root, I get a whole number. For instance, the square root of 1, 1. The square root of 4, 2. The square root of 9, 3. So I can graph that. There is a pattern that the square root follows. Once you find the starting point, the pattern is you go up 1, right 1, up 1, right 3, up 1, right 5. So you're always going to the right, an odd number, and it's the next odd number in the list. So 1, 3, 5. If we had room, we could go up 1, right 7. The other thing we want to do is find the domain and range. Domain. Well, we can get 0. That's the smallest value we can get. And then it just keeps getting larger and larger. Our range also goes 0 to infinity. So there's our parent, what we call the parent function for square root of x. A more, a little bit different example. If I had the square root of x plus 4. Again, I'm going to think of maybe making a little table of values, although I could also use the pattern. And I want to find the number to plug in there so that I'm taking the square root of 0. In other words, I'm looking for where is x plus 4 equal to 0? Well, if I subtract 4 from both sides, it would be at -4. And you may remember when we're adding inside of our function, like in this case, underneath the square root, that moves us left. Plus moves left. Again, you have your choice now. You can pick values to plug in, or you could use the pattern. If I use the pattern, I go up 1, right 1, up 1, right 3, up 1, right 5. And if I had room, I could go up 1, right 7. I just don't have enough room. If you picked values, I had 0, 1, 4, 9. So it would be -3, 0, and 5 would be my values corresponding to my Y values of 1, 2, 3. I kind of like using the pattern, less guesswork. Finding the domain and range, again, the domain, the X values, I can go all the way down. I can plug in -4, anything more than that, and I can't calculate the square root. And I can plug in any value greater than or equal to -4. The range, the smallest Y value that I get is 0, and I can get any value above it. The other function I want to look at is 1 over X. Here we're going to find the domain, the range, and then asymptotes. So just as a reminder, a vertical asymptote that occurs when you divide by 0. Horizontal asymptote is what we call end behavior. So let's see, our vertical asymptotes. What value would I plug in so that I'm dividing by 0? So I'm just going to take the denominator and set it equal to 0. And solve for X. Now I've got it already because it's just X in the denominator, which means I have a vertical asymptote, which I'm going to draw in red, at 0. That just reminds me, hey, I can't cross over that line. For the horizontal asymptote, what happens to 1 over X as X gets larger? And I think we talked about this earlier in the chapter. And as X gets larger, 1 over X goes to 0. Think about plugging in 10, you get 1/10. If you plug in 100, you get 1 over 100. If you plug in 1,000, you get 1 over 1,000. Each time getting closer and closer to 0. But positive when X is positive. If we let X get negative, then we still approach 0, but our values would be negative. So we have a horizontal asymptote at 0. We're not going to worry about symmetry. To graph this, then, I would look at some X and Y values. Maybe -2, -1, 1, 2, and just see what happens. At -2, 1 over X would be -1/2. At -1, 1 over X is -1. And I graphed the wrong point there first. That's +1/2. We want -1/2 and 1. And I know as I go further to the left, I'm going to get closer and closer to 0. And as I go further to the right, I'm going to get more and more negative. So this part of the graph is going to look like this. The other part of the graph, if I plug in positive numbers, 1/1 is 1, 1/2 is positive 1/2. So 1/1/2. At an asymptote, our graph is going to change. And we'll talk about that a little bit more on Tuesday. But it's going to go from positive infinity as we get closer and closer to x equals 0. And then as we get larger and larger, our graph goes to 0. So that's the general shape of 1/x. Checking this example, f of x is equal to 1/x minus 1. So I'm going to, even though it doesn't say to find the asymptotes, I think that's an important part. So x minus 1 equals 0. This is my vertical asymptote. Set my denominator equal to 0, solve for x. X equals 1. Is my vertical asymptote. Horizontal asymptote, similar to the 1/x. My horizontal asymptote is going to be y equals 0. Again, because we're taking x minus 1 in our denominator instead of just x, our graph shifts 1 unit to the right, minus and right. I can show that by picking values for x and y. I might pick -1, 0, 2, and 3. Notice I can't pick 1 because that's where my vertical asymptote is. -1, I would get -1/2. If I plug in 0, I get -1. And then it follows that same shape from our previous graph. If I plug in 2, I would get 1/1, which is 1. And if I plug in 3, I would get 1/2. So 2, 1, 3, 1/2. And there's that one. For your assignment, you are going to do 56B on page 386, problems 3, 4, 11, 12, 19, 20, 27, 28, and 35, and 36, all of the square root and reciprocal function problems. And I will be available and back on Tuesday to answer any questions. I will also post this video on the Schoology page in case you want to rewatch it or in case you missed anything.